In this video, we will discuss variation. Variation is the natural change from one particular sample to the next. The way we collect things will vary depending on the samples we take. It's important to understand why variation is needed. It helps us to distinguish between the usual and unusual values. In statistics, if we're used to seeing certain things and then we see something different, we further explore that different thing. Variation measures how spread out the data is. So what we're going to talk about are what we call measures of spread. The measure of spread that we are most common with, or that most of us know, is going to be the measure called range. Range tells us how spread out the data is from the minimum to the maximum value. The problem with the range is that it only accounts for two values in the data set, the min and the max. Therefore, we would like to develop a measure that can take into account all of the data values. That measure is going to be called the standard deviation. The standard deviation measures how far each data point falls from the center value. Generally, that center value is the mean. If we take the individual distances and find their average, so we add all the different differences from the mean up, we get a statistic that is known as the standard deviation. And the standard deviation is the on average deviation away from the mean. So we're going to go ahead and find that value now through this example. This example says, in a study of high school football players that suffered concussions, researchers placed the players into two groups. Group 1 consisted of 14 players that recovered from their concussion in 14 days or less. Those that took more than 14 days were placed in Group 2. The recovery time in days for each group is listed below. So if you look at this example, we can already see that in Group 1, there's going to be less variation because you had to recover from the concussion in 14 days or less. And in Group 2, it was more than 14 days. You notice here, look how big some of these values are in Group 2. And in Group 1, you're pretty much very consistent with your values. So the variation here, the variation in Group 1 is going to be a lot smaller than the variation in Group 2. Now, we're going to calculate the average deviation from the mean. And we're going to start by talking about what a deviation is. And we're going to use the Group 1 data to do this. To start this, we'll first find the deviations. Deviations are the positive or negative distance that the data points fall from the mean. What that means is this. Each one of these values is going to lie a certain amount away from the mean. In order to find that distance, we need to find the actual mean. If we calculate the mean using our calculators here, we can see that the value of x bar is equal to 7.5. So to find the deviation, we want to see how far does each one of these values deviate from 7.5. So to start this, we'll start with 4. Notice, 4 is less than 7.5. To find a deviation is equal to the observation x minus x bar. If x is less than x bar, you'll get a negative value. And if x is greater than x bar, you get a positive value. So data values that fall below the mean, such as 4, 6, 5, are all going to be negative values, while data values that fall above the mean are such as 9, 8, 10, 9, 8, 10 will be positive values, and I missed these, but these 7s are also going to be negative values. So notice you're going to have some negative deviations and positive deviations. So let's go ahead and find those deviations real quick. So the first one would be 4 minus 7.5. So this will be 4 minus 7.5, and that's equal to negative 3.5. And you have 7 minus 7.5. That's equal to a negative 0.5. 6 minus 7.5. That's equal to a negative 1.5. 7 minus 7.5 equals negative 0.5. then you have 9 minus 7.5. That's equal to a positive 1.5. Notice as we keep doing this, we're going to get these negative and positive values. So we'll calculate the rest of these. And here are the rest of the deviations. The ones in black are negative, the ones in red are positive. What's going to happen here is that the negative deviations are going to counteract with the positive deviations. And when you try to add these values up, you're going to get a sum of 0. And it just so happens that anytime you find the deviations away from the mean, the sum of all those deviations, when you add up all these different deviations, when you add up all these to all these, you're going to get a value of 0. And that's because that's what the mean wants to do. The mean wants to balance out the data. And it does it by trying to place itself in a position where all the deviations will be 0. So this is going to present a problem because we want to find the average deviation away from the mean. Well, how do you find an average? You have to add everything up and then divide by the total. We know our total here, or the total number of items we have, are going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going to divide something by 12. But the problem right now is that we're dividing and we add up all these deviations to find their average. We're going to get 0. And 0 divided by anything is just 0. So how do we fix this? Well, we move to a different measure. And this measure is called the variance. Because the sum of the deviations always equals 0, we fix this by squaring those deviations. And here's what the variance does. The variance is the sum of the average squared deviations. Key word here being the squared deviations. So what we're literally going to do is go back and look at all those deviations and square them. Squaring them does two things. It makes every deviation positive, and it also makes every deviation that is really far away from the mean become even bigger. And what this allows us to do is to see that if our deviations are really close to the mean, then we'd expect that value to be very small when we add them all up. And if our deviations are really far away from the mean, which means the values are very far away from whatever that mean value is, we'd expect that value to be very big. So here's how we're going to do this. We're going to square all those deviations. Squaring the deviations and then adding them all up gives us this value here. And here's how we write this. We call this the sum of the x's squared. That value is equal to 39. Once we get this value of 39, since we've squared the deviations, add them all up, we need to find the average. And that's going to give us the variance. We call the variance sigma squared. This is the Greek letter, lowercase sigma. And it's the population value for the variance. Remember, population means you know everything. It's the big picture. The problem with this, though, is that this is not a population. It's a sample. So we're going to talk about this measure called the sample variance. And the sample variance is what we call S squared. So again, this is the population, sigma. This is the sample, S squared. To find the population, sigma, if we know every value and we want to find the variance, we take this value 39 and we would divide it by the total number there, or total number of items there are, which are 12 items. So sigma squared is equal to the sum of the square of the deviations divided by 12. And we get 3.25. Now, the problem with that again is that this assumes that we know everybody in the population. And recall that this is a sample we're looking at. So we have an error here. And actually what we're doing to our our variance right now is that we're underestimating it, which means we're not giving ourselves a lot of error. And the problem with that is that we don't know every value, so we're going to make some error. We'd rather have more error than less error. And so to account for that, what we're going to do is this. To fix this is what we call this value. When we divide by the total there is, this value is called a biased estimator. It will always underestimate the true variance. It's always going to do that. So to fix that, we look at a value for the sample, which does this. S squared is equal to 39 divided by, instead of doing 12, we always divide by one less, which in this case would be 11. And this is equal to 3.545. Notice that this value is slightly bigger than this value. And that's because when you divide by a smaller number, you always get a larger quantity. That doesn't make any sense. Think about a pizza. If you're really hungry and you and your friends want to eat pizza, well, if you're really hungry, do you want to share it with 2 people or 4 people? Which one gives you a larger slice? 2 people. Same concept here. Would you rather share your pizza? If you're really hungry, you want more air, you want it to be bigger air, do you want to share it with 12 people or 11? 11 because you're going to get more air. So same concept applies here. When you divide by a number that's really small, you get something really big. But again, we're doing that because we need more air, and we need to have a what we call an unbiased estimator. And this right here is an unbiased estimator. And to find s squared is equal to the sum of x minus x bar. What is x minus x bar again? Well, this part is just a deviation. That's what that is. That's a deviation. And this sigma in the front means to add all of those deviations up. We saw previously, if you try to add up all the deviations, you get a value of 0. So how did we fix that? Well, we squared every deviation. Now, so we're adding up all the deviations and squaring them because we want to find the average deviation. Well, to find the average deviation, how do we do that? Well, we've added everything up. To find the average, you need to divide by the total. But we're not going to divide by the total because that's going to make this a biased estimator. We're actually going to divide by one less than the total, so n minus 1. And this is going to give us a unbiased estimator of the sample variance. This is called the sample variance. Now, the problem with the variance is that it is a squared measure. And in context, it doesn't have much meaning. So what I mean by that is you can think about what we're talking about now, the concussion, the number of days that we're trying to find, the average amount of days from the mean that we're trying to find. Well, right now they're squared days. Well, what is a squared day? It doesn't make any sense. So to fix that, we take the square root of the variance. So we take s squared and we take the square root of it. This is equal to s, which is the sample standard deviation. And this is the measure that makes sense. Because now we know that if we take this value, remember s squared was equal to sigma x squared divided by n minus 1, or in our case that was 39 divided by 11, which take the square root of this now, or 39 divided by 11, which was 3.545. In order to find s is equal to the square root of 3.545, and we get a value of 1.883. And this is the standard deviation, and this is the value that is unbiased. And if you notice here are your equations that we created. Notice that the population is sigma and is dividing by n, because you know every value in the population you can divide by n. If you know every value in the population, you don't need a lot of room for error. That's what this is essentially saying. But because we're looking at samples and we don't know every value in the population, we need more error. We're going to divide by n minus 1. But again, a formula is easy to follow and understand. Remember, you're finding the average deviation away from the mean. So to find the average deviation, you start out by finding x minus x bar, which is a deviation. If you try to add those, you're going to get 0. So how do we fix that? We square them to make them all positive. Then we're going to add all those up and divide by n minus 1, because that's how you find an average. And so when we try to interpret what this value means, is s equal to 1.883. We're going to interpret in terms of the context of the problem. And remember, we're talking about our unit of measurement was days. So this is 1.83883 days. Or we can approximate this to, this is the average number of days that are let's say that we deviate from the mean. So on average, another way of saying this is on average, we deviate from the mean approximately 1.883 days. Or since there's no such thing as 1.833 days, we can actually round it up to 2 days. So the on average deviation from the mean, the on average deviation from the mean is approximately 2 days. Now, there's a much quicker way to find the standard deviation than doing it by hand. I'm going to create a video on how to find the standard deviation using your calculator, using this exact same example. Be sure to look it up so you understand how to actually do this and the quicker way to get there.